Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, LADYADA, the engineer. With me, Mr. LADYADA on camera control. We're here at the Adafruit factory right behind us. Not a green screen, a real factory where we do our design, testing, coding, manufacturing, shipping, etc. of the goodies that you know and love. All the open source hardware that's manufactured here. We've got a jam-packed show for you, 1 hour of all the latest news for makers, engineers, hackers, and artists.
There's a lot going on.
There's a lot going on. Lots of new products, lots of videos, lots of guides, and more. So let's kick it right off. Mr. LADYADA, what's on tonight's show?
On tonight's show, the code is switchmode.
Ooh.
Use the code switchmode on checkout and get up to 10% off things that are in stock. And that code expires probably around 10, but maybe 11. All depends when I remember to turn it off after the show. Code switchmode, everything that's in stock. Use it. We'll talk about some of our Adafruit live series of shows, including Show and Tell. We have our segment Time Travel, look around the world, makers, hackers, artists, engineers. I got big news. Big news for people who care about open source. Help wanted. Jobs.adafruit.com has the skills that people have, and it also has the jobs that employers are posting up. We approve all of them. They're not spammy, and they're safe. Made in New York City, factory footage, and more. 3D printing, Noah and Pedro. We have everyone's favorite segment, Eye on MPI with DigiKey and Adafruit. Got new products, got some top secret. We're gonna answer your questions. We do that over on Discord, adafruit.it/Discord, where you can join all 29,000 of us over there, where we chat all the time, but we also answer your questions at the end of Ask an Engineer. All that and more on, yep, you guessed it. We're watching Ask an Engineer.
That's what you're watching.
That's what we're doing.
Right now.
Okay. So
where are you? Watching Ask Engineer.
That's what if you say, where am I? What am I doing? When you use the code, also, don't forget, it's switch mode, but when you use the code, we have free stuff that goes into your cart. So what's the first thing, LADYADA? $99
or more, you get a free Perma-Proto half-size breadboard, a PCB that you can solder to that looks just like a breadboard, but is permanent. That's the Perma. At $149 or more, you get a free STEM and QT board. We have different sensors and controllers and devices. We have a variety, about 20 that are in stock right now. Make an order, and you'll get a different one each time when you make an account, so we can keep track of which we've sent you. If you don't make an account, you just get a random one. $199 or more, you get free UPS ground shipping in the continental United States. And $299 or more, you get a free Circuit Playground Express, our favorite microcontroller board, featuring the SAM-D21. It's got 10 NeoPixels, 2 buttons, a switch, a buzzer, microphone, accelerometer, temperature sensor, light sensor, and lots of capacitive touch pads. It's an awesome way to get started with microcontroller programming because it supports Arduino, CircuitPython, MakeCode, Code.org, CS Discoveries, Rust, Lisp, and more.
All right. We do a series of live shows, and the show that we just did was Show and Tell.
That's right. Check it out.
Yeah.
Lots of MacroPad goodies.
Lots of MacroPad stuff from our team. Cool Tron desk thing that was 3D printed. The files were just put on Prusa. And then Stuart and his kid made this really neat Teacher Appreciation Award. I thought that was really cool. So check that out. It's all on our channels. And stop by every Wednesday, 7:30. We drop the link in Discord. Okay, we do a show called Desk of LADYADA every week. This week, because it was 4th of July, we only did the Great Search. And this week on the Great Search LADYADA, what did you show and share?
Okay, so the Great Search is a shorty, but it's a good one. Actually got a lot of views on the gram. I don't know if you knew that.
Yeah.
You're looking for parts because there's a global part shortage. And I shared an experience I had last week where we're out of, I think, max 31856s or 65s. We had a reel on order with DigiKey because we go through about a reel a year or so. And so we ordered a reel. But the reel hasn't shipped yet, but we ran out of parts. And so the team was like, look, I know we have this reel on order, but maybe we can get some just to hold us over. And that's when I realized that the tubed parts were in stock at DigiKey. Like, you know, even though we had this reel on back order, they had them available in a different packaging, tube, not reel. Is that okay? Yes, because we use a service, Argosy, which I show off in the Great Search, where you can order the tubes, send it to them, and they will tape the tube parts up for you for use in your pick and place. Your contract manufacturer will like you a little bit more when you send them tape and reel or cut tape instead of tubes. Tubes are not so fun to manufacture with if you have a pick and place machine. My pick and place, at least, does not like them. I've never really liked them. They're kind of a mess. So check this out. It's a shorty but goodie. We're dealing with chip shortage stuff day in, day out. Are you looking for a part? Are you having trouble sourcing an alternative? Drop us a line in the Discord at Adafruit, and we'll add it to the great search. We'll help you out find alternatives for your parts at DigiKey. I have so far been able to find alternatives for just about anything.
Yeah.
I just tell me what you're looking for, and I will put my magic fingers to work for you.
Yeah. LADYADA's House of Pancakes and Chip Service, brought to you by DigiKey and Adafruit. Okay. JP's product pick of the week. This is where we do a special broadcast inside a product page where the discount is automatically applied. Here is a clip from this week's.
The 2.13-inch monochrome e-ink display breakout. You can see here, this is a really gorgeous display. It's nice and high resolution. So you're going to see it's going to do its little refresh. There it kind of inverts the screen, does black, does white, and then it displays it. What I wanted to do is actually set this up as sort of a page-a-day calendar. I'm going to run a little Python script. It's now updated it with today's day and date, and that's grabbing it from my computer, which is what that Python script does. And so every hour, both my Python script and the CircuitPython script running on this little microcontroller will go and check. Essentially, the computer will check and see, hey, what's today's date, day and date, and then it's going to send that over serial on the USB over to the Itsy Bitsy M4. CircuitPython software there is waiting for input. And when it grabs that input, it then displays it up there. The monochrome 2.13-inch e-ink display breakout.
Okay, next up, JP's workshop. So JP's workshop is tomorrow, and I'm going to show two things back to back, which are a recap of a project he showed last week, and then a preview of what he's going to show this week. And rounding out the JP show portion of Ask an Engineer, we have CircuitPython Parsec. This is where JP does a really cool project or something and shows you some CircuitPython. Take it away, JP.
For the CircuitPython Parsec today, I wanted to show how you can read a rotary encoder inside of CircuitPython. This is really straightforward thanks to our rotary I/O library. I'm using one of our Trinkies that's made for running a rotary encoder, but you could plug a rotary encoder into most any microcontroller. What we do in CircuitPython is we're importing the board so we have some pin definitions, and we're importing rotary I/O library. Then with that rotary I/O library imported, we can do this. The encoder, this is the encoder object, equals rotary IO.incremental encoder. And then we point to the two board pins. In this case, the board pins are named Rot A and Rot B, which is super convenient. I want to print out when it turns its position. Then this is the main loop of the program. While true, if encoder.position is not the last position. So encoder.position, that's all you have to ask for to find the value of what the encoder is doing. As I turn this little knob here, that's turning that rotary encoder shaft, and that is being read by the little trinky there. The microcontroller is noticing those changes on its 2 pins, the rotary A and rotary B pin. And then I'm printing out there that change. So you can use this for things like volume controllers. You can use this for things like MIDI CC, for mouse control, for moving a mouse on one axis. There's a lot of ways to use it, but it is dead simple to use. And that is all it takes to read a rotary encoder inside of CircuitPython using the Rotary I/O library. And that is your CircuitPython parsec.
All right, and then Friday, Scott is doing a deep dive. You can see the demo that Scott just did with some web Bluetooth CircuitPython stuff.
Scott's the brain behind the idea of having auto reload on save, which is, I think, one of the coolest things about CircuitPython. I was not convinced at first, but Scott convinced me. So when he said I want to do the same thing for wireless programming, I was like, all in, do it up. I want to see how he transforms the way we work with over-the-air programming for Bluetooth and CircuitPython, and then maybe even Wi-Fi eventually.
We have USB drives that show up when you plug in a microcontroller now, and it automatically restarts and runs your code. We've got Whippersnapper, which is in beta, and now we're working on this Bluetooth stuff. One interesting, because one thing you said was at first you didn't necessarily agree that was.
I was like,
convinced.
That's weird. What do you mean reload on save? That goes against everything I know with makefiles.
And I'll say this as a sort of engineering manager that helps project manage some stuff. It's always great to work with people that are able to change their mind about things. So when you're especially doing something that's cutting edge or
sorry.
Yeah, you want to.
I'm sorry.
Cut my mic.
I'm sorry.
LADYADA is like.
Sorry, that was my foot.
She's like, I don't want to hear it.
No.
So.
My foot fell asleep.
Yeah.
Okay. Sorry. Continue.
But when folks who are dedicated to the craft, looking out for the users and the community, and want to make something good, they're able to separate maybe their first thought or instinct with good information. And then they're able to make a really smart decision. I've seen this over and over and over again with really successful engineers, programmers, just people in general. Folks that are willing to change their mind about something once they get all the information is
I love
powerful.
having my mind changed because it means I've learned something new. Like, if I'm right, that means I haven't learned anything. And I'm probably wrong. I know that I'm wrong a lot, but how would I know I'm wrong until someone proves me wrong? And I learned something and I changed my mind.
Yeah.
So I was really excited. So I'm really excited for this.
Yeah, and I think there's a lot of things that seem counterintuitive, and if you're used to a certain way, like dev boards have always been expensive and big and closed source, and there wasn't examples. If you think in that mindset, you're not, and you're like, well, we've always done it this way, so why would we do anything different? It's really hard to get innovation that comes out. So anyways, this is a really good example. Cool. We'll post this up tomorrow, and it'll also probably be recapped next week, but Scott's going to be on a podcast with Damien, creator of MicroPython, tomorrow, and details might be in the chat as well. Next up, time travel. Let's look around the world of makers, hackers, artists, engineers, and more. The first thing that we have this week is a special video from Phil B. Take it away, Phil B.
A lot of gadgets are described as being the size of a credit card, but in reality, you turn them on their side and they're kind of chonky. Check this out though, 1984 Casio SL800 calculator. It's literally the size and thickness of a credit card. I don't think that feat's been repeated since. Probably because it's fragile. You put this in your wallet, you sit down, and it breaks. Here's a broken one now. We can look inside and see how they did this. There's a cutout for the chip, which is hung upside down. You still see that on some devices today. And then the passives are these strange wafer-thin bits, very non-standard. So in 37 years, nothing comes to mind that replicated this credit card feat. Nearest I can think are the SIM cards from cell phones, which, by the way, originally were the size of a whole credit card. This little punch-out thing didn't happen until a couple years later.
All right, next up, some important AdaBox news. We are going to run out. So we're at the 100-ish threshold. That means we have 100 slots open. That's after we've just added a couple hundred more. We're going to be shipping them really soon. It's something that you're going to want. It's really hard to get a lot of things right now. So this is the only and best way to really pre-order anything on Adafruit. You don't know what it is, you can probably guess, but AdaBox will be shipping. Please, please, please sign up. Go to adabox.com. It also helps us as
Makes
well.
for a great gift, too.
Yeah. All right. Every single week, during the week, unless it's a holiday, which we just had, we have Colin's lab notes. So we're going to have Colin take it away. Here's the latest 3 episodes by Colin.
Polyamide, aka Kapton tape. Even if you don't know the name, you've likely seen it in use on multiple occasions. For example, on a lithium polymer battery, 3D printer heads, or even a USB jack. Not chosen for its charming amber aesthetic, polyamide is best known for its ability to maintain composure through a wide range of temperatures, from down around -100 degrees Fahrenheit all the way up to 500 degrees Fahrenheit. It won't get brittle, melt, or spontaneously evaporate like you might expect from a thin film material. It's great for attaching temperature sensors in hot environments, and when you need to secure a component in place for soldering, there's no better choice. Plus, it's resistant to chemicals, tearing, it's pliable, translucent, and it's also an excellent electrical insulator. So yeah, watch your back, duct tape. If you're looking to maximize the lifespan of your rechargeable lithium battery, keep it as close as possible to room temperature and don't store it in the fridge or freezer. When you do store them, try to keep them about 50% charged to maintain functionality. Over time, leaving them in a fully depleted state can cause them to permanently lose capacity or just die altogether. And as always, avoid anything sharp that could puncture the LiPo's casing and cause the internal chemicals to mix and leak and the battery to become puffy and possibly catch fire or explode. Yeah, a puffy LiPo sounds kind of cute, but it's not a happy thing. Switch mode power offers many advantages over the older technology used in linear power supplies. Switch mode power supplies are smaller and lighter as they don't require the large heat sinks and bulky transformers found in linear supplies. They're also more efficient. Linear supplies waste a lot of energy as heat, topping off at around 30 to 40% efficiency. In contrast, there are switching supplies out there boasting 96% efficiency. Pretty much every wall supply you see nowadays uses switch mode power. But there is a downside. Switching supplies can introduce noise into your circuit, both conducted and radiated. Proper RF shielding and output filters can do a lot to help reduce that switch mode noise. But if your circuit is particularly sensitive to fluctuations, you're best off using linear power, or the portable low noise option, a battery.
All right, so tune in for more Colin's Lab every single week here on Adafruit. Okay, Help Wanted. We're doing our best to grow the economy. And we do that by providing a free jobs board. And anyone can post their skills, or if you're a company and you're looking to hire someone and you're like, oh, like we do a bunch of Adafruit stuff, we use Adafruit code, or we do microcontrollers,
It's free on both
or do
sides.
whatever, you'll find some really good qualified folks. So this is a research technician full-time in Rockville, Maryland. You can check out the job listing and more. But basically, they're looking for a research technician to work at their headquarters, developing research instrumentation to study driver behavior for on-road and simulator studies. Bunch more details. Check it out. And if you
I love the jobs that come in because they're like really good jobs.
These are good jobs.
And they're for exactly the kind of people who read the Adafruit site. Like chances are if you're buying and making stuff with our electronics, or like following our guides or publishing stuff on our forums, then you're the kind of person who could be a research technician at this company.
Yeah.
Yeah. That's
All right.
cool.
It's not time for Python on hardware. All right, there is so much going on in the world of Python on hardware that we had to make a newsletter. And this newsletter, we're almost up to like 9,000 subscribers. I think it's the most subscribed to Python on hardware newsletter. So this week on the newsletter, we have a few things.
Yeah.
The first thing we have is we were celebrating how many guides we had.
Yeah.
So it's 2,500. That's a big deal.
Good.
Up to 2,500.
Lots of guys.
And then in our newsletter, we also point to our other newsletter, which we do, which is the Adafruit Internet of Things Monthly that comes out every month. We started to cover some things that I think will be interesting in the Python world, but it'll probably be interesting in the legal world soon. GitHub Copilot, it's an AI coding assistant, And the
I
controversy.
just think this is funny as hell. I know. I mean, like everyone's angry, but I just think it's hilarious.
I think we're actually at a point where we're starting to laugh at lots of stuff versus just get angry.
I think
this is
I
a
can't
healthy
be
way to
angry at
live.
it. I just think it's
Yeah.
funny.
So I was just like, oh, cool. Like, this will be interesting.
Yeah.
And so the controversy is that this GitHub Copilot thing was trained on all this GPL code. And it then inserts code when you want it. You still have to do stuff afterwards, like compile it and everything. But the debate is, should GitHub, Microsoft, be able to use all that open source code as a training set to produce code for people? And the answer is, dunno.
I mean, what the licensing doesn't specifically say whether or not you can train
Maybe.
data on it. A lot of code that people look, a lot of code like this example, it comes from the API documentation. You know, it's like, it's a little bit. It reminds me a little bit of the API discussion that just came up in the Supreme Court case between Oracle and
Google, yeah.
Google about Java. I remember when the judge said, well, it's like if you have a function that determines, you know, the max, like the, you know, max int, and it returns an int, whichever is larger, gives you the larger of the two ints. There's really only like one way to write it. Like at some point when your API is high level enough, there's no real other way to write it. So something that just copy and paste, basically is a copy and paste smart snippet writer, is there a de minimis of code that is not licensable because it's such a small amount of code and there's no other way of writing it because the API only works one way.
Yeah.
Do you know what I mean? Yes, it's like if it's trained, it's not going to write the entire program for you. It's like it's only going to make sense for small chunks of code because the longer your Markov chain is, right, the less sense it makes. So it works for small chunks. And the question is, what is the smallest number of lines of code that is non-licensable because it's so short?
Yeah. So I don't have an opinion on this yet because I'm still looking at all the arguments. There's arguments that are like, well, if we were to stop, we as a society and laws, if we were to stop GitHub, Microsoft from doing this, a music company could use AI to come up with every song that hasn't been even, every note of every song that hasn't been made yet, and just every time a new song comes out, just like, well, we already made that. You can't do that anymore because we've already did that. So there's a lot of like interesting thought experiments with this, but we'll see because I think it's going to be really interesting, and I think it's going to help people with their code.
I just know that all these lawyers are so excited
Yeah, they're
about
like,
this. This is a new flavor.
Yeah.
I've never had this flavor before.
Another approach could be where you use this in like, why don't you tell me if my code is definitely broken mode?
Yeah, I mean,
You
there's
know.
linters. I think an AI linter could be interesting too.
Yeah. Okay. Next up, the HP Prime G2 calculator supports 2 types of Python. That is right. More calculators,
Run in
more Python. So it has a couple different things. Next up, OshPark has 6-layer boards
Oh,
for
yay.
folks that are really into OshPark. Do check it out. They have pretty fast shipping. And then we went over a lot of the things that you can expect in our newsletter. But the highlight this week, and the thing I'm going to talk about, is mark your calendar, 8/6/2021. It's CircuitPython Day.
It's happening.
It's Friday the 6th. It's a snaky day. It looks like an 8, it looks like a 6. These are all snake letters, snake numbers. So that'll be the day that we do CircuitPython Day this year. So let us know what you want in the chat. We have a good idea. We're going to have interviews with people in the community, projects, kind of a whole smattering of things throughout the day. Other people will do stuff around the world. It's pretty much up to them. We like to have a hands-off. We have a central hub and things and Discord and stuff where we do things, but everyone is free to do stuff. And have a good CircuitPython Day. And that
Okay.
is the Python and Hardware News for this week.
Thank you, Blinka.
That's right. Okay. So I have open source hardware news. I got a few things, really. It's kind of a big week. So last week I went over the Arduino closed source libraries. And to be fair, and I think it's always good to be fair, is this is something that the companies that make the silicon, the actual hardware, they tend not to want to do open source.
And they always find like sneaky ways
Yeah.
around, which
So-
really drives me nuts. I
this
hate it.
this specifically, this article, and I just wanted to get clarification, and I'll just have to gather around, children, let me tell you history. So we have corresponded with the Arduino team many, many times recently and all throughout the years. And there's co-founders of Arduino, there's people we know, there's things that are said at events on stage, there's blog posts that they have, there's emails between companies when they're working on stuff. So I wanted clarification because it was really unclear, are closed source libraries allowed in the Arduino library ID, because they are the ones who say okay or not. So, good news, bad news. Most, if not all of the, or mostly, are open source in the
vast majority.
Yeah.
Vast
And there's a couple examples that are from companies. So Intel has a closed source blob. There's like uBlocks.
ST.
Yeah, ST.
uBlocks.
And then there's Microchip.
And again, this is for their own hardware where they don't want to release. Like I hate this. It's like the thing I hate the most about companies is it's like they write, again, it's not even that much code, but they're like so scared of somebody running that code on a different processor.
Yeah.
That's not theirs, right? Like chas v'chalila, right? And so what they do is they distribute a blob, and then they're like, there's a special license, you can only run the blob on their silicon.
So Microchip has this thing for their touchscreen and like whatever. So there's a reverse engineered.
There's
a reverse engineered open source version. Use that.
Works okay.
And so what we wanted was clarity because in the past it was not clear what was allowed and what wasn't allowed. So we got to the bottom of that. And the lesson that I learned is no matter what I was told in any format in the past, I should check with the people that are in charge of open source at Arduino now, because it might be different because things change. And that brings me up to my follow-up for this week. This week's follow-up, which I hinted to last week, was what's up with the Portenta? Because the Portenta says something different than any other Arduino product ever in their product history. And I'll just zoom in on it, and it said, study how the Portenta H7 board works using the following files. And this was the first time we saw a product that just had a schematic, which you can look at, it's fine, and a data sheet, but there was no downloadable, editable files. So normally when you get an Arduino board, one of the things you can expect is like, oh, there's Eagle files somewhere, so if I want to like make my own or like make an accessory or do things with it.
Or KiCad files,
Or KiCad files. But the whole idea behind open source hardware is it doesn't matter the file format. It could be KiCad, it could be whatever, but there's an editable, downloadable file somewhere. So the issue is that it's not there, but the site says it's open source hardware on the thing, and their about page says all of our boards are open source hardware, so I sent a note. And I said, hey, could you send some clarification just like before? So I got a response. Thank you, Alejandro. And basically what I did is I just said, so here's the board. We get asked about this. And we always refer people to the Arduino page, and the Arduino page says...
And historically, by the way, we've asked some people, is this open hardware? And they said, oh, oops, I forgot to put the files up. And they put the files up, and it's like...
Yeah, we get asked that all the time.
And that's fine, too. Either way is fine.
Yeah. And like there's always going to be like hardcore purists that are like, well, you used Windows to use KiCad, so it's not a really open source. So that, we're not talking about that. We're talking about like, are there files that are licensed that people could use? And so we would point people to the Arduino About page, and it says, all Arduino boards are completely open source, empowering users to build them independently and eventually adapt them to their particular needs. So that was different with the Portenta, and that's why we're like, hey, there's this thing. It's a Altium file viewer, but it's encrypted, and you can't download the files.
Right. It's even like called like GPG.
Yeah.
Which I didn't even bother. I mean,
you can't do
it's
that.
encrypted.
And there isn't downloadable files for the Portenta and their Pro line look like, so we asked. So here's the information we got back. The Arduino Pro is a line of products for industrial control robotics and other professional applications which is described in a separate website, arduino.cc/pro. They're sophisticated boards which are designed and manufactured to work in critical environments like the Portenta H7, and they require a lot of technology in the manufacturing process. At least for an initial period, we want to prevent counterfeiters from blindly downloading and manufacturing it without any R&D effort or contribution to the community, because the result of that will be tens or hundreds of low-quality clones which do not nearly have the quality of ours and no benefit for the community. This would confuse users and prevent these products from being successful because their value is not just in circuit design but also in their quality. These are not boards that one can manufacture at home or in a makerspace. We'll get to that in a minute. Other part. This is why we chose them for the same approach as Raspberry Pi. We publish schematics so that anyone can learn from them, and we keep the entire software stack completely open source. but at least for now, Altium files are only available upon request so that we can check whether someone can actually manufacture them with the required quality. We still wanted to publish an interactive web viewer from which design files can be viewed. Next up, we strongly believe in open source hardware since our origins. We sponsored the last OSHWA Summit too, and all the old and new products from our maker community are not only open source hardware, but are fully compliant with the OSHWA definition. Because we love that idea and other people can improve them or contribute ideas and even create new derived products. In this case, we're waiting a bit before making the CAD files available for download. Our approach is pretty open, but we acknowledge this doesn't fully match the open source hardware definition written by OSHWA. So to remove any confusion, we're making sure OSH, open source hardware word, is not included in the Portenta page.
And that's totally okay. Not a problem. Just want a clarification.
Yeah.
Totally cool.
So anyways,
People do not have to release everything as open source hardware. It's okay
yeah,
to say
In
I'm
fact,
not.
Don't.
Don't. I'm okay with that. I
We'll
don't
go
care.
over why we do it, but we don't.
Raspberry Pi doesn't even publish full schematics. Their schematics
Yeah.
are like weird, like sub-schematics.
Yeah.
They say that's what they're releasing. That's fine because that's what they say they're releasing.
If you do say a product is open source hardware, probably should make sure it meets the requirements, especially since Arduino is a bit of a poster child for this stuff. When people say open source hardware, they might refer to Arduino. So if there's a change, this Pro line is not open source.
Okay.
While that's probably disappointing to some, it's not a surprise at all. If you just look at what's been going on with a lot of the Arduino products, the more complicated they became, the less open they've been. This is like, what was the first one? The Wi-Fi Arduino. That's still not fully open source.
The Yan? Yeah, I don't
There's one that, yeah. And so it just seems to be, maybe it's a natural evolution of things. Like, I've been writing about Arduino for 15 years, and so I'll send this like link to the Arduino contacts I have there. Not a dunk, not a dig. It's just like, hey, we get asked, and we don't know. And when we want to stock certain things, we want to make sure it's open source or not. We just want to know, and the murkiness is the thing that's hard. Or when we're told something over email or in person or at a conference or an event, or just like the thing that we had to stick to when we were manufacturing Arduinos. If that's different, that's fine. Change is good, yay. Just let everybody know. So that's where that article came from, and I'm pretty much done. That's the bookend of the two that I had, was like, how is it working with the library manager now, and is there a hardware change that we should be aware of? So that is that. Next up, I have a mini follow-up. So last week was breaking news. We always assumed Adafruit would be the one to be in court first for patent infringement, because we had patent trolls that are very intimidating, but they did go away after we pushed back and said, hey, like, you actually don't have a patent, or like all these other things. So SparkFun, they posted up on their site. Nate has a big giant post, and it was basically about this PC Duino product that used an ARM core, an A9. And so what I did is I'm just like, that's interesting. Let me send some emails. So I found out two things. One, SparkFun is not the first open source hardware company to have a patent filing case go to court in some way.
Is that true?
It is true. It was Bug Labs.
Wow.
Remember a million years ago
I remember
out
Bug
there?
Labs.
So Bug Labs, they were the first one.
You can look this up in Pacer.
You can look it up. And it was similar, which was like, oh, like these, we make this microcontroller. So I believe they brought in like TI and ARM and stuff like that. So I thought, oh, I know people in ARM. I should email them and say, hey, like ARM, you're an IP licensor. How could someone possibly get a patent suit of license?
For your licensed IP.
Yeah, so here's what I sent ARM. And I'm sure the legal team is going to get back to me, and it's going to be great, and they're going to answer all these questions.
Or not.
So I said, hi. Hi. I even wrote in uppercase.
Oh, that's nice of you.
Yeah.
Okay.
Has ARM had a chance to look at the suit that was filed against SparkFun? And I linked to the SparkFun post. Does ARM think this suit has any merit? Has ARM licensed this IP for use in their cores? When companies license ARM for their microcontroller or microcomputer cores, does ARM indemnify the licensee against patent suits? So I'll totally post these up as soon as ARM gets back to me. I'm sure they will. Okay.
I'm interested to find out the answer, if any.
Yeah.
Okay.
And then some news I posted today, there might be an executive order for farmers to gain their right to repair certain things. So,
well, what am I, a gold farmer in World of Warcraft? Can I also get that right?
Yeah. So, I think there's some debate. They're like, oh, they're just doing this special thing for farmers, whatever. No, if we can keep going on this trend, let it start with farmers and John Deere and that like conflict between the two about like what they're allowed to modify or not or do things. Also, John Deere gets a ton of ideas from farmers and they turn that into equipment and other things.
Yeah.
So this is the world trying to be like software as a surprise or software as a service.
Software as a surprise.
Yeah, it's like surprise. You owe us
like
surprise. You owe us more money to run your tractor. So we'll see how that goes. But I thought that was neat. And in New York, this passed. It didn't pass one of the two in how New York law works. I think like not the state assembly or something.
Whatever.
Like that. So anyhow, we're still an open source hardware company. And we have 2,503 guides to prove it.
Okay.
One thing I'll just say.
What?
So there's a little bit of a debate on Hacker News about why companies do open source, and one person in the comments said, "Well, people do open source hardware because they don't have to do any documentation. They just put the files up and they're done." It's like,
okay, I would like you to find me a company that makes similar hardware to Adafruit that is closed source and has better documentation.
Yeah,
Find
it would be great. I would like to see that too. Anyways,
show me it so I know what it looks like when it's better documentation.
What's on the big board this week?
Okay, the two new guys we got this week, JP did a guide. You saw the video for the modal MIDI keyboard. This is like the software upgrade to the hardware he made with the Raspberry Pi Pico custom keyboard. And Phil B did an epic guide how to make the Adafruit macro pad, which we released, into a hotkey device with up to 12 keys, and then use the rotor encoder to change layouts. So I think this will be, I think Kevin Fujiki used this to make his custom overlay keyboard thing. So I think if you just want to turn your macro pad into a hotkey controller to send multiple key commands and have the LED light up and use the OLED screen, then check out this guide. It's very easy to make new overlays.
Okay. Next up, let's go to some New York City factory footage. Take it away, factory. And it wouldn't be New York City factory footage without, look how much they're building across the street.
Ooh,
now there's building. It's more than holding your own.
Now they're getting to ground level.
Yeah, this is Disney's headquarters or something across the street. Okay, 3D printing. Let's look at what's getting printed this week. We're going to do these back to back. This is the paw device. I think you'll get a kick out of it.
Kitty key paw macro pad.
And then a speed up. Take it away, Noam Pedro.
In this project, we're going to see if we can make a kitty paw keycap into a keypad. If you find squishing toe beans enjoyable, why not make the toe beans into buttons you can press? This 4-button keypad can be customized to trigger keyboard shortcuts. We really like musical instruments, so of course we also made this into a MIDI controller. We thought it'd be really funny to have Party Parrot animated on the TFT display. So each time a key is pressed, the animation advances a frame, so it looks like it's dancing. Based on the QtPy RP2040, this CircuitPython dev board is perfect for those creative projects. Featuring the RP2040, it's pretty much the only chipset you're going to get these days. It has just enough pins for buttons, sensors, and even an SPI display like the one we have here. Each toe bean keycap is 3D printed and press fits over these Kale box switches, and honestly they're really enjoyable to press. The parts list is pretty minimal on this one, just a few switches, the QtPy, and the color TFT. The enclosure is all 3D printed with parts that snap fit together and no support material. You can of course get the full list, links are in the description. The code for this project was made with CircuitPython. Liz Clark wrote the code as a good resource for projects with USB HID, MIDI, and a display. Liz made it really easy to switch between modes by setting it to either true or false. Be sure to get the whole breakdown of the code by checking out Liz's code walkthrough. The key codes and MIDI notes can be customized so you can make this do just about anything you want. So if you're just getting started with programming electronics, Adafruit CircuitPython is great if you want to quickly get up and running. Project Bundle makes it easy to download code from Adafruit's Learn system. Just click the button above the embed to get the code, images, and more importantly, all of the libraries. Unzip the download and simply drag and drop them onto your board's USB drive. Thanks to the Project Bundler, code has never been more accessible, maybe even for cats. The display and switches are mounted to a 3D printed key plate. The key plate is press fitted into the frame with the keycaps installed over the switches. The QtPy is also press fitted, it snaps into a built-in holder on the bottom cover. The bottom cover is snap fitted under the frame and lines up with the USB port. Lastly, the top cover fits over the frame with the display cover fitted underneath. Designing the enclosure allowed me to come up with a good recipe for making oddly shaped cases that need to snap fit. Using 3D models of the components really helps speed up the designing process, so I've made them available to download on our GitHub repo so folks can use them too. So there you have it, a keypad in the shape of a kitty paw. Who knew toe beans and kale switches would play so well with a Party Parrot?
Learn how to make all this stuff and more every Wednesday on 3D Hangouts with Noah and Pedro. All right, Lady Ada, you ready?
Yeah.
on NPI.
This week's Ion NPI is brought to you by DigiKey and Adafruit, and Analog Devices is Ion NPI this week. Lady Ada, what is Ion NPI this week?
Okay, this week's INPI is the LT3960. Linear Tech, of course, was purchased by Analog Devices, so this is a kind of a collab between the two. But since it's now owned by Analog Devices, they get the credit. So this is an interesting chip that popped up in digikey.com/new, and I'm going to make a breakout for it. So I picked up the eval board. What's neat about this chip is it is a chip that converts I2C into a CAN bus physical layer for transport. What that means is, as you see here on the left, you have a microcontroller, and it's an I2C controller or master. and you want to connect to a sensor or a device that's controllable over I2C, I2C peripheral. And normally I2C is meant to be like inter-circuit. That's what the I2 stands for, inter-circuit communication. And it's meant to be on like a single circuit board. However, nowadays there's so many sensors and devices that might be remote. You might have a temperature sensor, a humidity sensor, or a magnetic sensor, something in your robot or your automation. And you might want it a little bit farther or connected by wires that are longer than a few inches or maybe even longer than a meter. Or perhaps you have a lot of EMI because it's in a robot or something, there's motors everywhere. And I2C is a single-ended physical protocol. You have a ground, you have a clock line, and a data line. It's non-differential. It's designed to be simple because, again, it's meant to be in a circuit. But, we're engineers. We like to push the limits. So what if you want to have your I2C peripherals far away? Well, that's where this chip comes in. So sometimes, or normally, what you would do is you'd get a separate microcontroller and have that be on a CAN bus, and then it reads the sensor data and transfers it over CAN bus messages. You have this a CAN bus to I2C conversion. This doesn't turn your I2C device into a CAN bus device, but what it does do is basically transmit the clock and data as if it was like CAN bus physical compatible, which allows it to go very far distances. So if you look inside, there's no microcontroller. It's really just like a logic level differential signaling system. It's just designed very, very well. So this is the block diagram for one side, and each side can either be a controller or a peripheral. You can configure it either way. And then this is how it works. So at the top, you can see the clock and data. You see the clock going up and down and the data going up and down. And then kind of in the middle, you can see it converting each 1 and 0 into a differential or non-differential signal. So when the two clock lines or the two data lines are far apart in voltage, 6 to 10 volts apart, that's a 1, and when they're the same voltage, that's a 0. So this is just a much more EMI and physical distance and capacitive, insensitive way of transmitting data. Again, you can't share this on a CAN bus, but you can share multiple I2C devices on this bus using this transceiver. So here's an example of a multi-drop. So on the other side of this, you'd have the controller, but you can have multiple I2C peripherals either on one transceiver converter or multiple transceiver converters on your, as you can see, terminated, the 120 ohm is the terminated CAN bus physical interface. They call it I2 CAN bus, whatever, I2 CAN. And then you can see you can go quite fast. So this is, I think, 400 megahertz is pretty common. But depending on how long the distance of your cable is, you see the bus length. There's a calculation, depending on your twisted pair and the capacitance, it'll depend on it. But I think up to, if you're doing 100 kilohertz, you can either get into 100 meters easily. This is 400 kilohertz, and it's happily running at up to 15 meters. And that's assuming, you don't even do any special tuning or anything. And perhaps even you could do 5 volts differential instead of 3 volts, and that would get you even better distances. So there's an eval board that's available. I'll say that at the time of this filming, the chip itself is an NPI. It's not in stock, but sign up and get notified. There's an eval board, and I also got a separate eval board that is 2 endpoints that you can connect together. This one has a lighting controller, so you can use this to kind of test the cabling and distance, and then they have some Arduino code and Arduino library as well. So I thought this would be really good for is if you have, a sensor network, like you're doing agriculture or you're doing robotics, and you have your sensors spread out over a building or a very large machine, and instead of having individual CAN bus nodes, which again is totally fine, you can do that if you'd like, but before you know it, now you need a special CAN bus enabled microcontroller, and CAN bus microcontrollers are expensive and not, maybe you've already written your code for AVR or a SAMD or whatever microcontroller that you've already decided on and you really like for the pricing and other peripherals. You don't have a CAN bus peripheral in it, so now you have to get an external CAN bus peripheral. Before you know it, your bill of materials for every node is like $5 to $10. Instead, you can take one of these chips, the LT3960, and just stick it onto the end of this, and then you can use Cat5, for example, and here's a Cat5 to wiring converter. and then use some long Cat5 cable. Another thing that was kind of neat about this adapter chip is not only does it do that physical transference from I2C to CAN physical, but it also has it up to like a 40 or 60 volt input LDO. And so you could actually, if you had extra wires on your Cat5, not only can it pass the CAN data, the differential CAN data and the ground data, you can also pass a high voltage data power signal, right, 40 to 60 volts. And so that will easily survive any like really long distance wire that'll cause a voltage drop. Like you wouldn't be able to have 3 volts go over your long cable because it would drop down a volt by the end, and then now you have too much noise and you're not able to power your peripherals. But if you pass 20 volts or 24 volts and then linearly regulate it down the other end, you could have a really nice clean signal to power your end nodes. So I thought that was kind of a cool add-on. It's kind of a freebie you get with this chip. So I have a quick demo to show. Hold on, let me get my demo going here. Hold on. So what I've got here is a QT Py. So this is a SAMD 21, which just has a I2C connection. And I'm going to, hold on. I've clipped it onto this eval board from Analog, featuring the LT, hold on. Okay, featuring the LT3960. So, sorry, this is the mic controller. The mic controller goes here into the LT3960. And then over here we have a really long 6 conductor cable. I'm just not using the 6 conductor. And these two are electrically separated. They're mechanically connected, but they're electrically separated. And over here we've got an OLED screen, and then risky to do this live demo, but I think I can pull this off.
Super risky.
Super risky. I'm going to just power. This isn't data. This is just a powering it from a LiPo battery over here, just because the power I'm not passing through the cable. And then I reset this circuit, and voila! The microcontroller is sending I2C data at 400 kilohertz over this cable through this long cable, which, believe me, you cannot do I2C 400 kilohertz over this long-ass cable, to the other transceiver, which is peripheral, to the OLED display. So you can do very long-distance I2C, and even if I had motors or even a longer cable, this would work just fine. It's a great way to have I2C, a very popular peripheral controller protocol, but make it go super long like CAN bus. So it's like the best of both worlds.
All right, available at DigiKey, and we have the information here for you. You can look at the part number or the short URL. And
LT3960.
And that is this week's IWPI.
I on MPI.
Okay, let's remind folks of the code, and let's kick it off with some new products.
Okay. New.
All right, first up on new, there's a coming soon. It is, we liked it so much that we're going to stock it.
Yes.
DigiKey Innovation Handbook.
We featured this last week on the
That's right.
INPI, and we liked it so much, we're like, we'd like to stock it. DigiKey said yes, so it's in as
Yeah.
a coming soon. Of course, you can pick it up from
Yeah.
DigiKey.
Sign up so we know how many to get to, but
Yeah.
next up.
All right, next up, actually, this is a funky thing. I got these motors from CarveX. They contacted us and said, hey, we've got all these extra motors. Would you like them? We'll sell them to you at cost. And I was like, yeah, sure. I'll take some off your hands. So these are NEMA 23s. These are nice, chunky, big motors. I think they're 2.8 amps and like maybe 3 inches of torque. I don't remember exactly. Check the data sheet that we have linked from the product page. These are chunky stepper motors designed for CNCs. These are going to be great for controlling something that's either CNC or you just want like a lot of torque. They come with a cable. Here, as you can see, this is the X-Carve cable. So they come with a cable ready to go. You can plug it into here so you don't have to worry about getting the connector for this nice big wide pitch cable. It's very wide pitch. It's bipolar, so it has 4 wires. Nice big mounting plate. A GT2, I think it's a 2 millimeter pitch pulley already attached to it, so you don't have to worry about if you want to kick this up to your CNC or something. Yeah, it's designed for an X-Carve, but you can use it for anything you like. And I thought these were just really nice, strong, inexpensive motors.
Next up.
Okay, next up we've got our adorable custom woven cables. This is a USB-C on one end, a wonderful reversible USB-C. On the other hand, USB-A. I'm constantly using these kinds of cables. I want a cable that looks good. That wasn't just black, because everything I own is black. I like a touch of color, so I got these purple and pink woven cables with really beautiful overmolding. These are my favorite cables, and now they're in the store.
Next up.
All right, we've got more touchpads. So you, like a couple months ago, you said, let's get some like touchpads.
We need
and,
these.
Like, yeah, for like people making like I don't know.
You need
cool,
these.
Like Pi 400.
If a computer
like,
can be anything,
CyberDecks.
you still need a way to interact with the computer.
Well, I like these panel mount. So all these panel mount things is because like a lot of people are building projects with a Raspberry Pi and they want to have some sort of touch or mousing control. And it's really hard. Like a keyboard, we have a panel mount keyboard we'll show in a moment. Keyboards usually stay still, but mice are kind of like annoying because you have to have a surface for them. So these are all panel mount. This is from like some laptop, but it's adapted. You can just plug it into USB. Shows up as a mouse, has 3 buttons. It just works with any operating system. It's just a touchpad. It's even got the little scrolling thing on the side. So this is a panel mountable touchpad. It's basically left over from some laptop thing, but it works great with any computer.
Yeah, next up.
Okay, we've got this glowing trackball. I kind of like trackballs. Trackballs are kind of big.
We needed at least one trackball.
Yes, so let me see if I can grab this and maybe I'll plug it in to show the glow. Hold on, I've got this over here. Okay, so it glows. The glowing is not affected by the rolling. It's not like it glows more or less. It's panel mountable. If you open it up, there's LEDs inside, and like if you really wanted to, you could change the color. But it glows like a bluish white color. But it's just like your kind of standard video game or, controller trackball. Works pretty well. And again, I really like anything that has panel mounts, anything that you can like screw this down, attach it permanently to your surface.
All right, next up.
Zoom.
We have the combination of something you might need.
Yeah, so this is a full-sized keyboard. So it's big. It's a big keyboard. But it's panel mountable. You can attach it to something permanent, and it's got that handy trackpad on the side with the 2 buttons. It's simple but effective. I mean, you want a keyboard, you want a trackpad. We have them, but they're really small, and they're like wireless. This is the wired version that can be attached permanently, and it's full size, so it's nice and comfortable.
Yep.
I think this would be good. These people are always making products or like kiosks with our hardware, with a Raspberry Pi or a BeagleBone, and this would make a great accessory to let people control it with a mouse attached.
Next up.
Okay, this is something I personally wanted. It's a STEMMA QT cable, right? So it plugs into any of our STEMMA QT or Quick boards, and on the end it's got these micro clips, right? And
This is a good idea.
These are great. These hooks. They're not the ultra high-end, super expensive ones that you get on your $300 Logic Analyzer. These are the ones you get on your like $25 Logic Analyzer. That said, they work perfectly fine. You can attach to dips. You can attach to, so you can see breakout boards, wires, headers, SOICs, not TQFPs or obviously anything with wire, that is leadless, but SOPs or SOICs, yes. So even something on like a motherboard, you can if you can attach to some points, you can maybe get into that I2C there. So let me show this. I was doing this on my IMPI demo, so maybe I can zoom in and show how handy. I was just like,
tied all this together.
I was like, put this in stock because I need this for the demo tonight. So this is the hook, and you can see it's got this little hooky that can grab in, so you can grab onto like all sorts of stuff. And another nice thing I like about it compared to alligator clips is once it's clipped on, it doesn't have a big exposure, like there isn't a big space. Like alligator clips are so chunky, they're good, but like there's a lot of like, oops, like they're touching. This, it really hides, the hook hides into the body quite well. And then, like this, and then, look, I got these with a little bit of epoxy glue on them, so that they are mechanically more secure. I paid a little bit extra to get those. So worth it. Love this. Wonderful. Grabby.
All right.
Grabby hook.
Next up, the star of the show tonight, besides you, LADYADA, the community, our customers, our team here at Adafruit is...
More STEMMA QT boards. Okay, so we're getting back on the STEMMA QT train. This week, this is one actually from before March of last year, and it was one of the things that sort of fell off the new products train. But we're getting back to some of these oldies but goodies. So this is a 24C32 EEPROM. It's a 32 kilobit EEPROM, which is 4 kilobytes of data in EEPROM format. I like EEPROM because, one, it's I2C, so it's really easy to connect, supported by any microcontroller, microcomputer. 4 kilobytes is not a lot, but it's enough to store your configuration data, a key, a MAC address, calibration, username, display settings, what have you, over I2C. And again, these EEPROMs are so common; they're used by a lot. We actually originally stocked these because we use this part in our Raspberry Pi hats because they are used to configure the device tree overlay. But this is very handy if you ever want to add EEPROM to any of your products. A lot of microcontrollers that are simpler, like the AVRs and PICs, have built-in EEPROM, but a lot of the Cortexes I'm noticing don't. But if you still need a little bit of EEPROM data to store your configuration, you just plug this in, and there you go. So it's a standard 24C or 24LC. It's a totally standard way of using EEPROM. You can connect up to 8 on the single bus because you can configure the address using jumpers on the bottom. And we've got an Arduino library and a CircuitPython library coming out shortly that'll let you easily address them. Another nice thing about the EEPROM, you can write 1 byte at a time. You don't have to do page erase or page writes or caching or buffering. Each byte, takes a millisecond to write, but you can write them one at a time.
And that's new products. All right, while we're doing a little bit of top secret, go over to Discord. I lined up a bunch of questions, so we're just going to do top secret right away and show off some stuff. So first up on top secret is, so we got these clear bricks, and we put these, they're called wireless LEDs.
Wireless
They're
LEDs.
not. But this is what it looks like, and I got some close-up photos. And I want to be super clear. This has nothing to do with Lego, and I have a little video.
Does this have anything to do with Lego?
Well, I have a little video, and that makes it clear too. But I wanted to show how these work.
These are in no way associated with Lego. These are in no way associated with Lego. These are in no way associated with Lego.
Super cool. And then you have this.
Yeah, I'm getting into designing some hardware. I got to redo all my C-cell stuff in the ATtiny 807 or 816 or 817 family, and so I made a little breakout that actually came in, so I'm going to put it together tonight.
Yeah. And that is the top secret for the week. All right, questions. I'm going to load these up. LadyAda, we got a bunch.
Okay.
People want to know if that was associated with Lego. No.
It is not.
It wasn't.
Thank you for asking.
So first up, question for LadyAda. Is there a project that you've had an idea for and really want to do, but it's too cost prohibitive or something else prevents you from making it happen?
Well, I do want to make this atomic Trinky that Phil came up with, which is an atomic clock Trinky, but those like chip scale atomic clocks are like $3,000 or $4,000.
Yes.
So I have to wait till I somehow get one of these for free.
We're going to make an atomic Trinky, the most accurate timekeeping Trinky ever. Next up, I would love to see a LadyAda DigiKey search on fans. I'm using an Ender 3 Pro 24-volt power supply unit and looking for a replacement for the 24-volt fan for motherboard and hot end.
All right, maybe I'll do that on the next great search.
Can you summarize in one shortest statement why Adafruit is all in on open source?
I hate replication of effort. It just drives me crazy that to see people writing the same thing or designing the same thing over and over and over again. I feel like we don't get very far as a species or as a engineering discipline if everyone's constantly redoing the same thing. I mean, yes, it's good to redo stuff because you want to redo stuff, but I feel like we should be building on stuff instead of having it be like constantly reinvented because of licensing restrictions. I see it as such a waste.
Yeah. My short sentence would be, it's good to share information with other humans, and the act of sharing, much like lighting another candle, doesn't diminish the candle's flame. You get to share something, and they get to share it, and they get to share it, and they get to share it. And that's how societies and civilization and good people can all come together. So that's why we're all in on open source. Next up, is there an SPI version of the thing that you showed?
Not that I know of, although there might be, but I didn't see it immediately. So like you Google for like a differential SPI converter or a differential just like logic controller. I'll say SPI tends to be very fast, so you wouldn't be able to do it as quickly. One of the nice things about I2C is it's not that fast, right? 1 megahertz is like considered crazy fast in I2C land, but for SPI that's considered kind of slow.
Okay, I know automobiles use CAN, but is there any that use I2C?
Sorry, what?
I know automobiles use CAN, but are there any that use I2C?
They do on the inside, right? But it's not exposed to you.
Okay,
Probably.
pro cons of I2 CAN versus differential I2C via NXP's PCA 9615.
I think probably similar. The details of like which one can drive faster or like longer or be more EMI protect. Like it's not as affected by EMI. You'll have to compare the datasheet specs.
Okay. Does this I2C over CAN adapter enable communication with CAN networks such as in a car?
No, it's not actually CAN. It's like the physical layer of CAN. So you can't put it on a CAN bus. It's not a converter. It's just like a logic level converter.
All right. What is the popularity of the RP2040 compared to other microcontrollers in shop these days? Will the SAMD processor, especially the M0, still have their place in the future?
I'm still using and designing with SAMD and like you saw the AT-Tiny and STMs. I just can't get any right now. Whereas I can get RP2040s, and so
I'll say this.
I can design stuff with it.
All things being equal, if we can get unlimited amounts of each chips, I do believe that we would see the strongest sales with the RP2040 because it's running a scripting language, something like CircuitPython. You could do a lot with it. We have a lot of guides, tutorials, resources. People are building a lot of things around it. So, obviously the sales are more now because we have more of those chips. But if it was a equal 100 of this, 100 of that, I think people would be going to the RP2040. Okay, how do I2C address select jumpers work?
The chip has a pin that you can set high or low to change the address when it first starts up. So just check the data sheet to see what pins, if any, there are. Some have none, and some have like 8. It just really depends on the chip and whether the design of the chip exposes any address jumpers.
Okay. Going back to the Arduino stuff that I was going over before, does this affect Adafruit in any way? I'll straight up say we're probably going to sell more hardware because I don't agree with what Arduino was saying, which was like, oh, this is for people who are into robotics, so they don't need open source. No, that's the people who need open source. So I think the customer type is very different than it was 15 years ago when Arduino started. So the expectation now is if you're buying hardware and electronics, it needs to be open source. So I think people are going to look at one of our boards and look at one of our Arduino boards, and they're going to say, well, I get all these tutorials, these guides, these videos, the open source code, and if I want to go to manufacturing, I don't have to ask Arduino for like some Altium file or something if I wanted to put it into a design. So
Then again, if the customers don't care, the customers don't care. Let them decide.
I think the customers do care. I think.
Well, they have to say something that I'm not the customer.
Yeah, no, I think the customers do care, and like in our community and everything, I think they value open source, and I think they value open source hardware, and that's what I think. So I think it's going to actually, long term, it's going to increase our sales for things like Feather.
Sure.
If you have a choice of Portenta versus Feather, which one would you get? There's a whole menagerie and ecosystem of wings and stuff because we publish how to do that. We give out the files. That's what I'm saying. Okay, let's see. Robotics needs open source. Is Arduino support in the works for the itsy bitsy RP2040?
It is supported through the Philhauer core. We have a guide on using the Philhauer core. Try it out. It should work okay. It's beta, but it seems functional.
Okay, the Cricket board, it must be paired with a microcontroller. Altogether, it's about $50. Now that the Seesaw chip on board the Cricket is more expensive than the RP2040, have you considered making an updated integrated board? Oh, an all-in-one Cricket.
The cost is not really the microcontroller. Microcontroller is very little compared to the assembly cost and the size of the board and all the soldering that has to be done for it. The cost is not the chip. It wouldn't save that much. I'd save maybe 25 cents. It's not worth it.
Yeah. All right. Looks like we got to all of them.
Okay.
All right,
Thanks,
everybody. That is the question that we did.
Okay.
And thank you so much, everyone, for supporting us, an open source hardware company in New York City. Special thanks to Jessie May behind the scenes.
Thanks, Jessie May.
Doing things behind the scenes in our Adafruit Slack chat. All the people in the Discords, the different chats, thank you so much for joining us and being part of this adventure. We'll continue to be, I think we're one of the few independent voices for electronic news and publishing. We're not owned by anyone. We can talk about patent stuff, we could talk about open source hardware, we could talk about trends in the world, we could talk about chips. We are not beholden to anyone other than you, the customer.
That's right.
And our team. That's it. So that's our community. That's the people that you're our bosses. So keep supporting us and we'll keep doing this. Thank you so much, everybody. We will see you next week.
Thanks, everybody.
This has been an Adafruit production. Here is your moment of Zener.